first time. The dark understand.
All right, so we're gonna go ahead and get started. There might be some other people that straggle in here. Um, audio, piping helpers, and PMs. Um, so you know Josh Collins, he is one of our new piping helpers. So
Hi, Josh.
welcome.
Hello, Josh.
And what is your name? I'm sorry, Tommy.
Yeah.
Okay, you're a PM, right?
Yeah.
Okay, awesome. Columbus.
Tommy.
Yep.
Hello, Tommy.
New PM in Columbus. So at some point you probably will deal with us. So hopefully by then these guys are leads and they're not mean bullies or too aggressive. So um I'm so normally Barton teaches this class. He's out today. So I said I would gladly jump in and I'm gonna try and make it a little more applicable today to everybody in the room. So I'm not gonna talk too much about the properties of a split system, how it works. I'm gonna let him do that. So as far as every split system has a compressor, it has an evaporator, a metering device. I'm not gonna get too much into that side. I'm gonna get into everyday dynamics that everybody in this room is gonna deal with, things that you need to be thinking about to make sure we aren't behind from Josh when we're getting there. So um, these are pretty basic. If you have any questions, please ask. Um, that applies to anybody. So all right, so what is a split system? So has an indoor unit and an outdoor unit, as you see in the blue and the orange. Down at the bottom, you see they're connected by a refrigerant line, some electrical wiring. So an indoor unit is an air handler or an evaporator. Okay, normally mounted inside the building, contains an evaporator coil and a blower, and it circulates the conditioning. Connects to area that they're looking to cool or heat. Outdoor unit is condenser, compressor, mounted normally outside the building, clearly. Uh, roofs, our applications are roofs, outdoor concrete pad. Um, with that being said, what's that? Wall slinger. So yeah, so this is the general. I've made a diagram that literally shows you a lot of the little specialty items we use. Because I know from a PM's perspective, you guys hear, I need a wall bracket, I need a stand, I need trays, but you don't know what that looks like. So I put them on here so you can see it. And for you guys that are helpers as well, you've probably seen them. Most of you have, but you may not know what they're exactly called. So ordering purposes, stuff like that, you'll at least know what they're called. Also expels heat to the outside, is what the outdoor unit does. So as it's cooling, clearly heat, the fan is removing heat from the coils. Normally, always check IOMs. That's where we get our clearances. So I know a lot of times people will be like, oh, keep it this far off, keep it that far off. The book tells us everything we need to know. So in our IOMs, that tells us, we've set units inside of almost completely walled off spaces with just one access. As long as we have all of our clearances, tops and bottom, or top, sides, we're good. All right, so the IOM, you're gonna learn real quick when we go through this, that the IOM is like your vibe to units. And I know it's hard because on the PM side, you're asking for IOMs and you're getting submittals. Normally you're getting submittals, not all the time you're getting IOMs. On our side, I'll see stuff on the submittal sheets and I still have to go to an IOM to figure out what I actually need. Because on the submittal, it'll say, yeah, it's power, it's 208, it's 230. Sometimes it'll say low volt communication, other times it won't. And yet I won't know until I go to an IOM and actually look at the electrical panel and say, okay. I will tell you splits, the reason they're so easy is because they're really labeled pretty hardcore. So inside a split, it's going to label, okay, this is an indoor to an outdoor. Like it'll say it right on the board. So it makes it pretty simple. But yeah, so we'll get into that some more. All right, tools and materials needed. So this, if you want to print out of this, I can print it out for you. The big thing, tools, you guys know what it takes in the field. The materials is more of the big part to get everybody thinking about ahead of time. Everybody thinks a split is simple, it's easy, it's a line set, it's a wire, but there's a lot of crap that goes into it that if we miss any of that, you take a 1 day job, just made it a 3 day job, and they didn't bid it for 3 days, they bid it for one. So then I gotta sit in a meeting and explain why it took 3 days, not one. So, please think about it. All these things are different things we use. So line sets, does anybody know when we use double insulated and when we use single insulated? Why I'm sure everybody's seen, sometimes it's double, sometimes single. So heat pump, okay, that would be what type, double or single? Double, okay. That is true, but not in all cases, okay. The time that varies, if you have a vertical upright air handler, the TXV, the metering, if it has a metering device inside of the cabinet, you do not have to insulate that liquid line. So, because it doesn't change state until it gets to the TXV. Anytime we do it on wall mounts, on sets, the reason we're double insulating is because those indoor heads have no metering device. So when it comes through, it's coming through just like it would on the suction side. So the temperature is going to vary from the space it's running through. So if it's not insulated, as soon as you get a 30-degree swing, so if it's 20-degree line coming through a 70-degree space, anytime it's over a 30-degree swing, you're getting condensation. And then you're going to get a phone call that says, hey, my ceiling's falling through because it's a soaking wet line. So
They swing when you get difference.
temperature difference. Temperature
Side,
difference.
in, outside to inside.
Temperature of the pipe, right? So refrigerant correlates to temperature. So if I got 410A and I know when it runs through that line, that temperature of that, when it's in heat or cool, being a heat pump, whichever mode it's in, what temperature is that going to be at? So if it's okay, it's going to be at 40 degrees. And I know inside it's 74. I'm over 30-degree swing. So you could subtract those two. If you're over 30, you're going to have condensation. And then at that point, that's going to be a headache no one wants to deal with. The other things you need to think about in line sets, honestly, line sets is one thing that I stress more about. So when we get a job from the PM, normally the first things I do is go into the IOMs based off the fact of, I'll throw it out there, Daikin right now is probably one of the worst, if you want to call it Daikin, whatever you want to call it. When I say the worst, I mean, so they show port connections. It'll say it's 7/8, 3/8. It's a 3-ton unit. We can all just say, okay, cool, we're going to run 7/8, 3/8. Well, then you go to the IOM and they actually have a table laid out. If it's from 0 to 25 feet, you can run 7/8 to 3/8. If it's 26 feet to 49 feet, now it's 1.8 3/8. Well, the problem with that is we're not running, none of our pipers are running 1.8 in soft copper. No one wants to bend 1.8. It's crazy. So difference for us now is time, because it's going to take us much longer to install hard copper than it is soft. You don't get hard copper pre-insulated. You get soft pre-insulated. So the time alters substantially for us. It almost takes twice as long to do hard copper than soft copper. So whatever their bid would be, it would be double. That's something I communicate to Dan and them regularly when we run into this kind of stuff. But that's why I go to the IOM, because you won't know unless you look at the IOMs. In the past, people has been told the connection to the outdoor condenser, that's good, just run with that. Well, that worked 30 years ago, but that don't work now. And the manufacturer's not going to warranty what you don't do. The other thing with that is the wiring. I've had Hank and some people have asked me to put together a wiring to where it's like standard. If you're running this unit and it's a 3-ton, what kind of wire do you run? And I said, I can't even do that because every manufacturer is different. Samsung on 16.2 shielded wire on all their splits that are above like 24,000 BTU. Normally, and I'm saying normally because you can't quote me on it, anything under 24,000 is normally a 14.4 wire, but I just saw a change in that with can't remember the manufacturer, but someone had a 12,000 BTU unit. It was a 1-ton wall mount, and it had a control wire, 18.2. So again, the IOM is where you find that. So you can look at a submittal, and there are submittals that will say, I'm not telling you you can't go off submittal. I'm just telling you to verify. Because if you don't, it could burn you. I will tell you, it burns us frequently. Guys in Columbus, I'll tell you to heads up on the wire because we sub it out to Milky, any of those guys. Normally they're not touching the wire. The electrician didn't have it in their scope. So you're calling us at the end of the job going, I need someone to pull a wire and everything's drywalled and it's up 4 flights, 4 stories. And we're like, yeah, sweet. We love this. So just stuff to think about. Mounting brackets. Well, I'm sorry. Let's go to liquid tight. That's simple. Anything outside, it's weatherproof. So any wiring we do outside, for you guys' sake, piping guys, know that we don't have to seal tight. If it's outside, it goes all the way back into the building. We don't leave bare wire outside. If we do, that's going to break. If you also leave bare wire out and the seal tight's open, water's going to get in and then water's going to freeze in the winter. And then you're going to mess up the communication with the unit. Okay. Note that.
You're saying IOM, just clarify what an
Okay,
IOM
an IOM is an installation manual. That's all it is.
It'll come and then.
Installation operation.
If for some reason you don't have one, you can look up the unit's model number and you can find one.
So from you guys' point of view, normally, you pipers, we've already ordered the line sets on the front end. Got that? Your verification comes when the units are on site. Pull the book out. I know it takes time to read the book, but we wouldn't have as many callbacks if people would just read the book. Because there's trap details, piping details, there's wiring details, and I can't tell you how many times we go back just because it's like, dude didn't read the book. So, get it? Might take a little time. I don't want to take from your personal life, but at the same time, if you want to learn and understand, take the install manual out of the unit home with you and read it on your way home. Sometimes you're driving from Cleveland and you're not driving, the other guy is. You look on the way back, understand it. All right. So I had to clarify that because there is a job that we did not liquid tight all the way, and it was kind of frustrating because that's simple.
Make sure you bring the O and M's back.
Yeah.
You always want those.
Yeah, they have to be back at the unit. Don't take them.
Download them offline. We don't usually get the IOMs until towards the end of the project. They just know how to send it to us. You can use this metal, the IOMs come close out.
Yeah.
But that way you can also control find and search for whatever you need.
So that's where, so on our side, we don't ever normally have the IOMs on the front. So I get online and search up the unit model number that's on the PO because you can't even look at the schedule because it changes, it adjusted. We don't have that unit, but we can get you this one. So I go to a PO of an actual unit we have that's coming and I'll look up that. You can find it online. An install manual comes online. So, yeah. Outside of that, mounting brackets, if it's a heat pump, it's got to be off the ground. There's no, because what happens is it'll go into defrost mode in the winter. And then as that water pours off, it's not off the ground, start to accumulate on the bottom, freeze, crack your coil. So we've had to deal with it a couple times. And a lot of times you don't realize how bad it is. I can tell you, we have a job in Canton that we did, VRF systems underneath, 2 foot off the ground. Winter, it was really, really cold. Well, they defrost, full of water. There's 12 inches of ice under these units. So I'm like, we want them up. They all got to be up. If you don't see them, question it. All right. So, and that's normally where our bracketing comes in. So we have wall sling brackets, stands. Yeah.
How high is it? Is there a minimum, like is that an IOM too?
Normally so in the past, we've only put them on 6-inch pump ups. Moving forward, we want to kind of be 12 inches or higher. Just cover this. On a roof, we're normally putting in 24-inch pates. Porthole's not so much an issue, paint's on.
You just have to specify what the PMs do. So a lot of times the specs only call for 12, 14, 16-inch curves. That's what we ordered. Try and make them uniform, so if we find one that's 20 inches or 18 inches. The highest, we just make them all 18, but that's, I was gonna ask, that's
Yeah.
normal, a 12-inch monocoque eyes? Where's you?
I think it all just, on VRF, everything's a little bit more, it's a little bit more intrinsic than splits just because you've got 40 rooms going off one outdoor condenser. So the defrost mode is gonna kick in more. So no, it's not as big of a deal. But I do know. I mean, outside on the ground is normally our lowest, and we're normally 12 inches. So it's outside of the building. On a roof, I normally always see 20, 24 inches. So that's just because roof, it's the open area, gusts, snow, it catches on a unit and builds up. So things to think about. From a PM's perspective, paints and portholes, normally you guys order ahead of time, so just be thinking about that. There's submittals in the folder. We like when the paints have, so for splits, VRF, all that, the strut welded. Because in the past, we would have to put strut to bolt the units down, and we'd be screwing through the paints, which is then a leak spot. And they're like, well, you need to do this or do that. And we're like, why don't we just weld it right on the caps? So think about that. We want welded strut on caps for when we're doing outside stuff. Portholes, we always do the dog extenders, and I got some pictures so you can actually see why we do it that way, because our Seegers come out. The whole reason we built the dog extenders for the portholes is way back in the day, the old portholes, we just put a cap on it and a rubber boot, and there'd be 4 taps that you can cut, run our pipes out, and then the electrician would come out one, and he would always come out at the very end. When you're done, he'd come out, wouldn't seal it, wouldn't clamp it, and then they'd call us and say, yeah, your penetration's leaking on our ceiling, and you better get out here and fix it. And I can tell you, I've been to so many jobs where you go out, an electrician just ran his crap through, hugged it open, and it was pouring through his hole. You know. But, so that's where we started doing those portholes, because now we go outside, we've eliminated that on our side. So, just something to think about. Wall sleeves and the little white exit grommets, they're called Seegers exit grommets. So if you didn't know that. Wall sleeves, we should be sleeving brick. I mean, metal. The reason I say metal is because if it's sharp, it's going to cut the insulation. It's going to cut that pipe. You're not going to notice it as much, but when that pipe is sitting there attached and the compressor's running, if we're 5 foot away from the building, that compressor is going to vibrate that copper a little bit. And if it's touching that metal over time, that metal is going to cut through the copper. Then we're going to lose refrigeration. We're going to be screwed. Okay, cut this, pull it out, redo it. So these are why we're doing this stuff. Also, we got to make sure that we're sealing our penetrations at the very end, once everybody's through. So line set, wire, once everything's out, make sure we seal it so there's no air going in to the wall. There's no animals climbing into a 3-inch hole that's still open. So something to think about. Refrigerant, most splits come pre-charged, but again, the installation manuals will tell you if you need additional, and it's based off of line length. So if I've got a 100-foot liquid line, it'll say, okay, it's charged for 25 feet. So then it may say, for every foot additional over 25, you need to add 0.21 ounces. Well, then you would times that by whatever your additional footage, and that's how many ounces you need to add to the system to run. I noticed a lot of guys, I think that everyone's got pretty good about it, but in the past, a lot of guys weren't adding it. So then techs would go to site, start up and go, slow, gotta be illegal. And it's like, no, our guys didn't add the additional charge. So make sure we're doing that. When the leads are doing it, ask, hey, how are you calculating that? Learn that ahead of time. That when you become a lead, you're ready to roll. Condensate drain. PVC or copper? Those are always questions. You cannot run PVC in a plenum ceiling. So not code at all. So if you know it's a plenum ceiling, does anybody, our guys are probably gonna be like, what's a plenum ceiling, Eli?
Those ceilings when there's no ducted return. So like you're supplying the air in the space, and a lot of time you'll see a return grill, it's just the return grill. So all that air is going back up. And it'll work its way from one room to the next room to the next room till it's back up at the unit. So that conditioned air is technically in the space.
So it's pretty much they're using the space where we're running our stuff at the return. So all that air flowing through there, cycling back out. The reason you can't have PVC, because if a fire ever happens, PVC, once it lights on fire, poisonous, and it siphons right back into the space. So, yeah. So that's when we're using copper. Well, as far as condensate drains, when you guys go to site, always find where our condensate drops are. The designers have been getting better about it. They don't always show us where we're running our condensate. So they're like, oh yeah, this is, oh, just run the condensate. Always ask the question, if you see condensate going out a wall, up out, if someone says, hey, we're taking it out, just ask me, hey, can we do that? Some splits you can't do that. If it's a designated IT room and it's good run cooling year round, we probably shouldn't take it outside. Now, could we? Yeah, based off the fact of normally in the winter, the reason that it's creating moisture, condensation, is because of humidity, but it's dry in the winter, so you don't have to worry about it. So that's a little deeper. We can have that discussion at another day if you don't quite understand that, because that's a process. Teardrops, silent glides, hydrosorbs, these are all things we use to hang. These are all the material we use. And then hardware. Hardware is a weird one. It seems simple, everybody knows it, but nobody grabs it. So nuts, washers, make sure you're getting your hardware, or else you're gonna stand there and be like, I got everything I need. I don't have any nuts. Screw the strut out. Don't waste your time. Don't waste our time. Just get it. Safety gear. I'll tell you guys, let's start making sure. I know we get the jobs. Yeah.
I have a question. So when we grab hardware, right, the hardware get charged through the job. So we have to, like, when we grab hardware, we have to say, hey, grab this amount of hardware.
So it should be going on a parts request, just like everything else. When you put it in, whatever you grab, say you got 300 nuts. Okay, I got 300 3/8 nuts, and then you can put right in your description, grab it from stock. So then they can document it, put it towards the job and bill it.
All materials, right? This is what we're supposed to do it for all.
Correct. But a lot of times, I'll tell you, a lot of times stuff in the shop get missed. People, oh, I'm in a hurry. I got to grab this, grab that, grab this, grab that. Next thing you know, Susan's going, hey, no one's put any stuff down for this, but we're out. But no one's been billing it, but we don't have any strut. No strut's been billed. And then,
Go to get it. Yeah.
yes, and there's none.
Order it. So it's not, yeah.
We got right in. If it's a small size.
Yeah, they have paper software and
I know we could have just writing on paper, it's all name and number, it's a shop guys.
But, so that's for them.
Every job.
Yeah.
Number.
So that's for them. On our side, it'll be on our field app. Yeah, on our field app is how we'll do it. So write down what you take and then put it in on NSB later. Pulled from stock. So, but as far as the safety gear, I get it. You guys go to job sites and there's a GC walking around without a hard hat on. He's like, listen, man, I'm cool. If safety guy comes out, he's out on here on Monday. I don't really care what you do. We're trying to create a culture here of being safe though. And I don't know about you guys, but I know when I was in the field, when I would walk on site, and there would be, say all the electricians are wearing their high vis, their safety glasses, their hard hats. You think like, these dudes are serious, like they're professional, they care, right? Whereas then you see another guy standing on the top of a ladder, taking a piece of wood, trying to smack something in, you're like, oh, this dude's he's gonna get killed. So safety gear is important. I know we have a safety guy. We should all be operating safely. We're at that point. So, all right. So these are some of the things I was telling you about. So Seagrass grommets, what we do with those are things we drill through the portholes and we seal it, and then our pipes run right out of the porthole. Hydrodrope trays, we use those on strut. You can also put them in a 2.5 inch teardrop, and it pinches tight at the top. Doesn't look as good, I'll tell you that. If you're gonna do that, I've seen guys do it. I don't think it looks as good as a clevis hanger with a shield pump. That's the wall mounting bracket. I know a lot of PMs have asked what kind of condensate pump we use. Gobi 2. I recommend that. There's been Aspen mini whites that we've done in the past. I'll tell you, there was a job that we did up in Cleveland. We ran it. It said it can run 33 feet ahead. You can pump it up 33 feet now. We went like 29 feet, and there was water flowing back down in the wall, filling the space below. Because, yeah, well, it can run 33 feet, but when it goes 33 feet, it pumps nothing because it can't pump out that 33 feet.
Another thing with those Gobi pumps, they come with that little green, it looks like a check valve. It is not. I think some guys do get confused and think that it is a check valve. Also, it says very clearly in the instructions that it is to be at the highest point in your run. I see sometimes they are 6 inches away from the pump and that they're dripping. The Aspen pumps say have 6 feet away from the pump.
Yeah.
Well, maybe the Aspen.
Again, that goes back to when you do the condensate pumps, read the IOs, read the manuals. One thing, I'm just gonna be honest with you guys, frustrates me a little bit is when I get phone calls from guys asking how to wire in pumps. There's a manual in there that tells you, hey, the one wire that comes down, wire nutted to the purple wire. I mean, they're all color coded. It's dummy proof. It's so easy that I can do it. So, wall mounting brackets for PMs inside the job folder. There's a submittal folder. If you go down in the submittal folder, I'm sorry, they call our department special forces, so I apologize for that, but that's their problem. There's a special forces piping submittal. You click on that. The very top is a quick reference guide. So whatever we're doing, whether it's chilled water, hot water, split, tells you what type of material we're going to be using. Then below it is tons of submittals on what we're going to use. So line set, ProCrest fittings, copper sweat. And you could drag that, toss it in to your files and send it. Because I updated it, and that's the material we are currently using on some. So to make it easier for you. I love it will, but line hide. If you haven't heard of line hide, this is what people talk about when they say, I don't want to see your ugly line set on the outside of a wall. I want you to use line hide. So condenser ground stand. I like them a lot. They look good, but we just had an incident where we had a pad. It's a little smaller than the stand. And as water started to flow down this gutter and get into the ground, the whole thing shifted. So now the condenser's leaning like a foot one way. Customers like it just keeps getting worse. So, yes.
What if it's a heat pump? And it's gonna go into deep frost. Those small enough? The air is.
Yeah, he missed his opportunity. We went over this earlier, but yes. Because you can, they're adjustable.
Like when we put a roof curve down, it's 20 inches above the roof.
No, you're talking about the pump up. Me, I put it on here so you know what it is. We've used them in the past. You're gonna see them. I don't order them. I'll tell you, they're garbage.
Yeah.
Because they're 6 inch, you can get them in 12 inch, but then you got to mount the, I'll tell you, the reason I don't like them is I did a job with 53 splits. I put these on every one, bolted down through them, put them on a deck, screwed into the bottom, and then I got a phone call 2 months later, said, we had a bad windstorm, you need to go out. 27 of those things blew up. And when I got out there, the whole tops of the plastics cracked and broke. So the plastic was still on the deck, but the whole top of it was gone because it was bolted to the unit. And I'm like, yeah, we shouldn't do this. We should make it legit. So I don't use the condenser pump ups. I try not to. I try to ask people to use the stand. The stands are much easier, more compact, and they look good. But in saying that, when you guys are putting the stands up and mounting them, make sure they're secure. Don't put them on a mulch bed. that just got laid where it could drift.
What's the? Honor home, they had that big plastic pad.
Yeah.
That arena was on, what is that exactly?
So that's just a plastic pad.
Oh,
It's just a 36 by 36, yeah.
Oh, okay.
Sometimes they'll come with stuff like that. Not everything has to be lifted. If it's just a simple AC unit, we're not gonna lift it up. I mean, one of them square residential style, we're gonna put it on there.
So
But you'll see people call them splits still. So
somebody got that one, so they would have just more concrete pad, basically.
they don't have to. You can leave it there and that's fine.
Okay.
I mean, in that case, that's on the customer because we moved it for them. So whatever the customer wants, we can give all our recommendations, but ultimately they're paying the bills. So as far as the steps, plan, permit, that's more on the project management side. They'll have a good plan. They talk to the front end. Honestly, if you guys have any issues on the front end, you can call me, Josh. We're in here. We're willing to help on any of that front end stuff. Some people think that doesn't mean I'm going to do your job. Okay. But what that means is I know if I help right now, it's going to stop these guys from having to figure it out in the field and we can figure it out ahead of time. So when it gets to them, we can have a higher expectation of just get it done. We've already figured out that side of it. So, mount indoors, mount outdoors. We will help. But again, if it's ducted, sheet metal guys should be doing it because their ductwork is going to be a lot harder to manipulate than our line sets that we can bend over and come back in. And normally they're bigger. So if you have a ducted unit and it's a 36-inch by 8-inch opening and they've got to blow it up to a 24 by 18 or whatever they're going to do, they need a lot more room than we get. So if it's something that's ducted, we prefer that they set the unit. And then as far as cassettes, wall mounts, we have no problem doing those ones. If you want us to hang a ducted unit and you say, hey, they can't get out there, I want it done so you can pipe it in and be done and get out of there, we'll do it. But we'll do it. But at the same time, we're going to go off the print. So if the print's bad, or if the sheet metal guy said, oh, I wanted to move it, again, that's something we're not going to be able to adjust off of. Okay. Support for you guys, we need to support the line set every five, I would say 5 feet. We do 6 feet and then there's a sag right in the middle. Unless you have shields. If you have shields, you can go 6 foot on centers because the shields extend 6 inches past the clubs. So, communication wiring, electrical, we were talking about that. 14.4, 16.2, 18.2. Those are the main ones I see. 14.4 is always a weird one. Everyone wants to know, does the electrician run it? Do we run it? Normally, on a 14.4, we're running it. The electrician is bringing power into the outdoor unit. We're running a 14.4, that black wire that we run. That sheath around it is outdoor, it's rated for outdoor, okay? So we can run it in, tie it in, it's just simple. They'll land L1, L2 ground, and then we would technically call our 14.4 wire a communicating wire. The reason that is because number 1 and number 2 of that, or S1, S2, L1, L2, those are the high voltage coming in to the unit. Number 3 is a variable DC signal that's running our communication. So the reason we like to run that, because electricians break wires and put disconnects on indoor units and they break that communication wire. And I can tell you, I've had to pull a million more wires because, yeah, he ran all this and broke it right there and it wouldn't work. And they're like, yeah, rerun the wire. That's what the manufacturer says. Yeah, you can't break that, rerun it, and we're leaving. And it's like, okay, so we're kind of screwed. So the new question would be, is I've been telling people, I might get corrected for this soon because I'm going to bring it up to Dan, but they've started doing, if there's communication that runs from inside to outside, there's also the power feeds from the outdoor to the indoor. I've been started to tell people, if you see that, run the 14.4 and the communication wire. So we have them both. Because still electricians are like, oh, I didn't have that on my scope or didn't. We've already got the wires there now. We ain't got to worry about pulling back through. It's becoming more and more common. As So with these A2Ls, with the new refrigerants and all this stuff coming down the line, how much more communication things they're putting in there with leak detection systems and all this kind of stuff. I'm seeing way more communication wire coming off of splits now than I am just a 14-4. The only one that seems to have it mastered that they'll let you run 14-4 to anything they have is Mitsubishi. But we don't buy that because no one wants to pay an arm in both their legs, and it's normally priced high, but we love them. So yeah. Also, the other thing to think about with that is it shielded or not shielded? That actually matters. I'll tell you, we've had instances where people say, just run shielded, it'll be good, right? Because everybody knows what a shield is, right? So if I have an 18-2 wire, it's gonna be two connectors coming through. They're gonna be sheathed single in the same piece of insulation. And then there's a bare wire that runs through it. That bare wire wraps to the ground. And what it does is it eliminates interference from the communication wire. So nothing can come in between that wire. Okay. We ran for a while. We were saying, just run shield. It's cool. We'll have the shield if there's an issue. We don't have to use it. And then Daikin, whatever you want to call them, we ran a bunch of shield and they said, yeah, you can't run that. And I said, well, why not? It's not tied into either side. We taped them both off. And they said, no, it's acting like an antenna. And I was like, it's not tied to anything. It's not touching any metal. They said, yeah, we don't care. I said, okay. So we ripped a bunch of wire out because at the end of the day, the manufacturer can say, yeah, no, that's not what we spec, and then we're not warranting it. So then we rip it out and run new. Again, so think about that. Vacuuming, charging, pressure testing. A lot of you already know microns under 500, got to hold. Again, it's all in the installation manual, so they want pressure test. We like a 24-hour pressure test. So that's planning, right? So if I know I'm going to be there 2 days, the first thing I'm going to do is I'm going to get there. I'm going to hook up my line set both sides. I'm going to pump it with pressure, and I'm going to take bubbles. And if it's flared on either side, I'm going to check flares. Okay, it's not leaking. I'm good. I'm going to leave it now till tomorrow. Now I'm going to start doing the drain, wiring, start tying everything else in. Where's the thermostat go? Does it need a pump? Start figuring all that out. Okay. So the longer you can have a pressure test, the better your system's going to be. I will tell you, pressure test isn't going to take you that long to learn that it's maybe the most important step we have in everything we do. When we do big VRF systems and all that kind of stuff, if you don't pressure test, you're going to want to jump off a bridge. Because I've spent 4 or 5 days straight looking for a pinhole leak in a 3/8 line with 6,000 feet of copper in this building. And everybody's wanting to jump because it's like, I don't know where this freaking thing is. We lost 10 pounds overnight. Well, maybe it's not a leak. Okay, well, let's leave it one more day. Come back next day. Another 15 pounds down. And I found a pinhole leak 5 floors away off a branch box. That was a connection that was from the factory. Right? But if I would have pressure tested that ahead of time, sections, I'd have known, hey, that ain't holding. It was. So I can't stress the importance of that because if you don't have a pressure test and you get to the end of a job, normally at the end of jobs, it's go, go, go. We got to start this unit, got to get it going. Commissioning, we've set up a commissioning for this day, needs to be done. Pressure test has to hold. Okay. Vacuuming, charging, you're not going to achieve a vacuum without a pressure test. It just ain't going to happen. I'll tell you, and I'm just trying to debunk some theories that you may have heard. I've done a vacuum test. I lost a little bit of pressure and I blamed it on, well, it's cold out, right? So it was warmer out yesterday when I put it in and there was some moisture in my nitrogen tank. So I lost 10 pounds overnight. So that's probably not a leak. It's just, it's much colder this morning than it was yesterday. And I put a vacuum pump on it and I got it down to 200 microns. Now I would think everyone says that's good. I valved it up and it climbed 5 microns an hour. Not that bad. But the manufacturer said, we want to be there when you do it, and it's not allowed to climb more than 12 microns in 4 hours. Because some of the manufacturers get crazy. He's like, yeah, you got to have a leak. And I'm like, you're nuts. Like, I've been told there's no way I'm going to be able to hold it. Sure enough, I found a leak. So if it keeps climbing and keeps climbing and keeps climbing, if it stops and it holds, then you're good. It may just be moisture in the system or something if it goes over 500. So suck it back down and verify it. All right. Line set, key details. Suction line is always the larger line. Liquid line smaller. Suction line is carrying low pressure refrigerant. It always needs to be insulated. Suction's always insulated. Doesn't matter what system we install, suction's insulated. It varies based off of what type of equipment. So if it's a bigger, say it's a vertical air handler inside, bigger outdoor unit, we might have to up the thickness of the insulation wall. So that's why we're not always getting 1/2 inch insulation. Sometimes we get 3/4 inch or 1 inch. That's what it has to be on that equipment. So know that. Liquid line, smaller diameter, goes to the expansion valve from the condenser and then into the evaporator coil. Best practices. Keep the bends gentle when we're bending. Sometimes you got to take a hard bend and then just people being around it, hitting stuff, ends up folding. And then we're screwed. We got to cut it out, redo what we just did. So, yeah. Pressure test. These are some, like, pretty much the procedure to do it. I'll probably end up printing this out and giving it at least to all you helpers, so you guys all know, or all of you guys. So you'll know, you have it, you can use it. You know what I mean? To test. We kind of already went over this. So common installation mistakes to avoid. Okay. Incorrect line sizing, see it all the time. And if it happens, I'm telling you, 9 times out of 10, you're ripping it out. We've had instances where it's like, oh, I ran this size, it doesn't work. What you do is if I run different size, I'm losing efficiency, I'm losing the capacity of that unit. So if I have a 5-ton unit and I run too small of a line set, it's only going to give them 3 tons. Well, now I'm screwing the customer because it's going to run longer. It's never going to satisfy. If a manufacturer sees that, they're going to say, yeah, it's because you did your job wrong. Pull it out and start over. And that's what we got to do. Over tightening flare fittings. Flares are rough. We have tools. We've tried to make it as easy as possible. The tools clutch, they break away when you're done. There was a time when you used to have to stop yourself. There wasn't a clutch tool. And you over tighten them, you have cracks, not clean. If there's any discrepancy on a flare, cut it off. Don't put it on. Like I've seen, even at Hoban, when I went out there, I know there was a ton of different guys doing stuff. I know everyone's like, oh, this guy did this area and these guys did this area. There was one person out there that was doing terrible. Like it wasn't even flared. Half of it was flared, half of it wasn't. I'm like, what are you doing? Like, so in that setting, flares are important. Once you put the flare on and pressure test it, just put the bubbles in the flare. Just save yourself because a flare will only leak. I've seen flares leak 2 pounds overnight. Just take the bubbles and check it after you pressurize it, and you'll know right then and there if they're a leak or is they're not. And if not, then let it set overnight. Okay. Wrong wiring sizes. That is the biggest thing we have to repull stuff for. And that's especially on y'all's side in Columbus. So just something to note. I've had to pull more wire in Columbus through finished spaces because, oh, this guy said he didn't have it. That guy didn't have it. You guys now get it. So think about it. For y'all, it seems a little minute, but insulation gaps in line sets, that is a problem. It's got to be tight, glued, taped. I always liked butting it tight together, and then I would wrap Armaflex tape around it, and then zip tie that. The reason I do that, because now that I'm in this position, I go back out into the field, and I see jobs where we did really good. I have pictures of great looking work, but a year later, that insulation tape's hanging off the pipe, and there's gaps because it doesn't stick and hold as much as it should. And then if that's the case, there's leaks, condensation's dripping down on things. and a customer feels like we failed. So do that. Make sure we're doing that. Make sure that we're adding the additional charge. Already talked about that. And then improper condensate and venting on things. If we end up venting an indoor furnace, read the book, read the IOM. You're not allowed to go so far with certain sizes. Just because the taps off the top for an intake and an exhaust 2-inch doesn't mean you could run it in 2-inch all the way. There's literally a book that'll say it's over 20 foot, you got to up it to 3-inch. Okay. And what that means, that doesn't mean, oh, I got there in 20 foot, but I have 390s. That means every 90 is 5 foot. So if you have 390s, that's 15 foot. You can only run a pipe 5 feet. Then you got to upsize it to 3-inch. So make sure you're thinking about that stuff. If you don't understand it, ask me. No issues. I'll help. Condensate, high efficiency furnaces that are tied into split is what they'll call it, a little residential unit outside. High efficiency, all of them have a condensate off of the inducer motor. I go down, tie in. So you tie off the coil, condensate comes off, cool, we're good. We got it tied in. No, you don't. There's another point halfway down the furnace. You open, you put the adapters on, pop it out the side, heat it together and take it down. All right. Again, it's in the IOM book. So make sure you're reading that so we don't miss it. All right. This I am definitely printing out for all y'all. It's like a little checklist for all these things. You should be able to check when you're done. When you're done, you should be able to say, okay, yep, system's good. It held below 500. It's secured. I think our department's biggest struggle sometimes is cleanliness at the end and making sure that the simple things are done, like bolting the unit down all the way, or making sure it's snug, make sure, we zip tie things together so it looks nice and neat, clean. Not just leaving, oh, look, the line set comes up and this piece of seal tight runs separate from that. Looks bad. So make sure we're doing our due diligence. Yeah, so you can go through that whole checklist and you'll be able to see it. So that's pretty much it for me. But now I just have some pictures to show you guys kind of what we have. So that's the stand condenser. That's what it should look like coming up, going in, silent glide, zip tie it, make it look nice and neat. Customer don't want to see that, we would line hide it, right? There's different colors of line hide. So we try to match the building as close as we can. So it's inconspicuous. Those are our roof boxes. Not everyone uses the box, but it is in the submittal folder. Again, that's what I'm talking about when I say strut tack welded to the top so we can bolt right to it so that we don't have to screw the strut down to the lid. And then it's secured that way. Here are some examples of wiring. So L1, L2, and ground on the right side is where the electrician came in. S1, S2, and S3 are R3 wires that go out. So S1 and S2, those are 2 legs of power. So that's our 230. S3 is our communication. If you break that blue wire, it's going to mess up our frequency to our unit. And we could have issues later. Same thing on the left side. Only difference is this is the indoor version. So 1, 2, 3 is what would come in, and then we have a ground. You see the wire nut there? Someone tied in a pump. Pump's underneath, clearly. The left picture. I know it's a little hard to see. It was the one that I had. So this is an example of one with a communication. So L1, L2 by themselves on the far side is where the electrician came in. L1, L2 and ground. The 1 L1 and the 2 L2, that's coming off there and going back into the indoor unit to power. So that's the power to the indoor. S1 and S2 are just communication. So that's where I've been telling people, pull them both. Now on this job, the electrician did it all. So sometimes, normally more in Columbus, the electricians got a lot more of that on their scope. So, but they also miss it a lot more on their scope there too. So just something for you guys to keep your eye on.
Screenshot of the camera.
How do you take a screenshot of a camera?
I mean, I know how you do it, but I mean,
It wasn't my camera. Yeah, so,
I mean, I understand.
Yeah, I don't know.
Like you're at the camera and you think.
Right.
What's he trying to take a picture of?
I have no idea. You could take a picture and send it, I agree. And then lastly, oh. So this is what I was talking about when I was saying cassette. That's the left side. It was kind of hard to see. But I can tell you in that instance, that's gonna suck for the great guy. He's gonna be mad at us. Uh, because those, for everybody in the room, the cassettes are the hardest thing for us to hang, based on the fact that we don't have leniency on our condensate because the cassette has to sit in the ceiling grid. And in the ceiling grid, you're only a half inch normally is what you have play because the grill goes over it, tightens below the ceiling grid. So with that being said, those units can only normally pump. They say, oh yeah, they can pump 26 inches. That's from the face of the unit. So when it's all said and done, we only got 14 that we can come up off that unit. So keep that in mind as far as we've had some instances where guys are like, oh, well, this one down here, we're gonna have a ceiling height at 8. And that one down there, we're gonna have a ceiling height at 10. But it's all gonna run from there down or from there back. And it doesn't add up because the ceiling height's changed down through it. And we couldn't get our condensate to flow. So is that?
So to add a pump on something like that?
Sometimes we did. So we would have, so they've got a pump built in. We pumped it up, and we put another pump on top to pump it in, and then pump it. Negative with that is, anytime you have 2 pumps installed in one system, have fun with that alarm. That alarm wire that goes off when it says, hey, this pump's bad. It's hard to tie. Their pump's internal, and they have it tied into their control board. We have an external pump that now we've got to tell the other pump to turn off when this one goes bad, and it turns into a nightmare. So normally if the exterior, we get worried because if the exterior pump goes bad and the internal pump's still good, it's just gonna sit there and pour on top and then it's gonna flow off on that. So, but we have done it before, we can do it, but again, that's on you guys, us, to make sure that we know we gotta time that alarm wire if we have a double pump for sure. That unit's gotta be able to shut off. Okay. And then the unit on the right, those stupid things on the front that have slanted, those are wind baffles. So you're probably gonna have to install those at some point because everybody loves wind baffles. Purpose of a wind baffle is because when those units are sitting on a roof and the wind's blowing, it'll spin those fans in reverse. And then what it'll do is it'll create amperage in the motor and it'll harden the muscle. Had it at a building and or hail or something. So does anybody have any questions? None. You guys are perfect. So thank you all for coming. Actually has, for all you helpers and guys that are in the field, I had her print out some packets of ProPress fittings, says all the fittings, sizes, stuff like that, so you can learn how to order them, as well as sweat fittings, like the difference between them. You can take them. If you want to use them, you can. If you don't, I'm not telling you you have to. If I get a message saying, hey, this guy ordered this and he ordered it wrong, I'm gonna say you knew better because you had a packet.